This is the tutorial about the specification part 3A of the asset administration shell. Part 3A is the first part of the part 3 series, and this is a series about the data specifications defined for the asset administration shell. 3A is about the standard IEC61360. So, first a little bit of history. So we are talking now about version 3.0 that was released in April 2023. And the first version was published in 2018 in the context of the platform Industry 4.0. And now the association, the Industrial Digital Twin Association, is maintaining all of these specifications. And today we are talking about specification 3A. This is the overview of the specifications we have so far. And yeah, again, the repetition 3A. This is what this tutorial is about. And here, just perhaps for your information, there is also an IEC standard for the complete asset administration shell. In work, it has the number 63278. For whom is this tutorial? So this is not a tutorial explaining why you need digital twins and which business cases and use cases and so on. So this is assumed that you have an idea why you are interested in this specification and why digital twins are a good idea to implement. And I also assume that you know tutorial part 1, or at least know what it is about, the meta model, because they are very strongly related, 3A and part 1. It's good to have a little bit basic, but only really basic knowledge in UML modeling, because the specification is using UML for explaining the relationships between the different elements. And the tutorial is either for architects who want to learn about the underlying information model of the asset administration shell, or for developers who want to implement the asset administration shell, or who want to update to the newest version, to version 3.0, and did already have an implementation. If you feel, if you now listen in and say, oh, that's too much, that's too deep, then I recommend to have a look at the reading guide of the asset administration shell, because there you find a lot of other sources for information on the asset administration shell for decision makers, for software developers, but also for other stakeholders. So this is a stakeholder-oriented reading guide. It's quite short and gives a very good overview on the literature and for whom we recommend to start with what. Okay, then I would recommend to first download, of course, the specification. You find it at the Industrial Digital Twin Association. It's part 3A. And some of you might also want to want to have a look at the UML and play a little bit around, though there is also an XMI. So this is a standardized format for UML modeling, and you can use it and import it. Please note that 3A and part 1 are very strongly related. We call it an embedded approach, and this is why you find 3A as part of part 1. So this is the same XMI file. So you may import it into your own UML modeling that is supporting the XMI standard. What is always important, and the red boxes are mainly important for those who did already an implementation, because there I will explain the differences to previous versions. There is an annex, Annex E, that also explain all the changes that were made for release 3. And also, if you already listened to the tutorial of version 3.0 or release candidate 2, then you might know already about 3A, about this data specification, IEC61360. And so here you will find all the differences. So this is the older tutorial. This is now the tutorial for 3.0. Okay, so UML, just a very, very short overview on the most important concepts of UML that you need to understand so that you can read the specification. And the first one is for sure inheritance. And what is important here is that these three representations are identical. They are just different representations. So this is probably the one you know, this arrow. And it's saying that class 3 is inheriting all attributes of class 1. And this is a short form. If you don't have both classes on your diagram, then this is just depicted like this. On the right upper corner, it's saying that class 3 is inheriting attributes from class 1, and they are not repeated. If you want to have them repeated, then it's looking like this. In this case, you are repeating all the attributes of class 1. Then the second concept is shared aggregation, and this is a very important concept for the asset administration shell. And in previous versions, we used two different ways to model it. They are identical, but in this release we are always using this notation, so with a diamond, and it's stating that class 1 is consisting of class 2 instances. And how we implement it, however, is via a so-called reference. This is a reference class. And so referencing is a very important concept, and I really recommend that you have a look at the tutorial part 1 again to understand the referencing concept of the asset administration shell. Enumerations are depicted like this. So in reality, there is no real inheritance for enumerations in most programming languages. This is just for seeing the logical relationship between them. So this is the enumeration 1 that is consisting of two literals A and B. And this is how it's written in the specification itself. So we have some tables like this. So I will not explain everything, but you can have a look at the annex. There everything is explained if you are not sure how to read these tables. For those who know the previous specifications, there was a change. So for model references, before it was a star, now it's written like model reference, and then what is the element of the meta model that is referenced, and then there is no kind column any longer. Okay, and this is just an example. It's an example of part 1. This is a property with 3 attributes. This is the class. It's inheriting from data element, and that's how it's written. So this is inherits from. It has these 3 attributes. These are the types and the cardinality or multiplicity. Okay, so also I assume you had a look at the tutorial of part 1. It might be some days or weeks you had a look at it. I will repeat the most important concepts that are relevant to understand specification 3A. And okay, this is what 3A is about. This is not a very large specification. It's about these 5 classes only. It's mainly about this class. This is data specification IEC61360. And this is now part 1, and from part 1 there are 3 classes that are relevant for our context here. First, it's of course the template class data specification and the data specification content. And what we are defining now is the data specification content. And the data specification 3A or IEC61360 is used for concept descriptions. This is why concept descriptions are also circled here in gray, because not every data specification makes sense for every class, and IEC61360 is about semantics, and this is why it's a data specification for concept descriptions. Exactly, semantics. And also from part one of the most important concepts is the concept of semantics. Has semantics, the semantic ID of elements within a submodel or of the submodel itself. Here you find an example, and you see there is a value 2000, and you don't know what this means. It might be the year 2000, 2000 euro, steps, whatever. And this is why you need to have a semantic, and this is the unique identifier of the semantic. And it's typically showing to a dictionary. In this case, it's from E-class, and here you find, this is the identifier again, and here you find the semantic descriptions, and then you know, it's the maximum rotation speed measured in rotations per minute. Here. Okay, and yeah, so there are two ways to use the semantic ID. It's sufficient to just add these unique ID, but it's also possible to have it as a model element, as a concept description. And then we are again in the meta model of the asset administration shell itself, where it is modeled. This is good if you want to provide the information about the concept within your file, within your payload, whatever, or if you want to define semantics that is not yet available in existing dictionaries, then in both use cases you would define your own concept description. And this is the class has data specification from part one. It's inherited by several classes, but in this case it's the concept description that also has a data specification. And for the concept description, we are now defining the data specification IEC61360. So now I said that it's very closely related, 3A and part one, and this is because we are using embedded data specifications, and this is explained here. This is how the data, the meta model is defining it, but this is how it's implemented in the different formats. We defined it's really embedded, it's an embedded data specification, and so it's part of the concept description in the end. Yeah. And what we are now defining is the data specification for something like this, what I just explained, to define the semantics of a property, for example. Before we have a look at the data specification itself, we have a look at the standard IEC61360, because it's necessary to understand what we are modeling and what this standard is about, to understand why the meta model looks like it is looking like. So yeah, you might read a little bit about it in the Wikipedia. You can also yeah, it's not for free, so but perhaps you have it in your company. If you are using dictionaries based on the standard, please always be aware that there might be licensing issues or usage policies. So it really depends on the dictionary you are using, because the standard, of course, it is also costs something, but yeah, you can. It's just a meta model for defining dictionaries. So what we are now modeling is first the property. This is a simple property. It's a measurable property, so there are also properties that are not measurable. You see that it's measurable because it has a data type called, where is it? Oh, I don't see it. It has a, here, integer measure. This is a data type. So the measure means, okay, it must have a unit, and this is a unit here, rotation per minute. And you see it's blue, so in reality it's a link, and if you click on the link, also the unit will have a unique identifier, so that it's really clear about which unit we are talking. So this is also very important. Of course, such a property has a preferred name. It has a definition, what it is about. These are the most important attributes here. Preferred name, and of course a unique identifier. In this case, the IRDI standard is used for defining the unique identifier, but there are also other ways to define unique identifiers for concept descriptions. But in this standard, it must be an IRDI. Okay, then what we also very often have is just a value list. For example, here we do have, it's also an example from E-class. We have a cooling type. And a cooling type, there are different types of how to cool something. And here you see it, air heat exchanger, closed external air cooling, and so on. So a lot of different ways for cooling. And as you see here, every single value in this, I would call it an enumeration. It's a value list, but every element within the value list has, again, a unique identifier. And this is where we come to the next element that can have a unique identifier and define semantics. And this is a single value. And all of this we can also model with a concept description. So here you see it again. This is an example. Here we have the value open circuit. This is a unique identifier of the open circuit value. And if you have access to the E-class Advanced, you would also have some more information about the value. Then this is something very specific, and we do not really recommend to use it, but you will find standardized properties using it. It's a so-called level type. There are 4 values for the level type: min, max, and nom. Normally there are 4, but in this example it has 3 types. In reality, these are now, it's in this case the outside diameter. It has 3 values. It's like a record or a struct with 3 attributes: min, max, and nom. And this is how it's denoted. This is an example now from the IEC dictionary and not from E-class. Okay, so this was the introduction, a very short introduction, of course, to the standard itself, but these were examples for the most important elements you find in such dictionaries. And now we have a look how our data specification meta model is looking like. So you already saw it. So here you see the data specification. It has a preferred name, as I just showed you, though this would be the maximum rotation speed in this example. The data type, it has a data type here. This is the one, and the data types that are allowed are defined in this enumeration, as you see. I will come to this enumeration later. It has a unit, rotation per minute, and the unit is also here. We have it both. It is either the symbol for the unit and the unit ID, and this is again a unique identifier, so to really make it very unambiguous. So if you really want to be very sure about the meaning, you need to have a unique unit ID. Yeah, and then of course we have a definition, and the definition is here. This is the definition. It's a string with a defined length. This is why it has a special type. But in reality, it's just a multi-language string, of course. You can have, and that's very important for concepts, the definitions are typically in many different languages, and also the preferred name is given in many languages. Okay, and then this is also important because if you had a closer look, you will have noticed that there is no ID. The ID itself, the IRDI we saw in the examples, this is there the ID of the concept description is used itself. It was a design decision whether to use also this description of the concept description. So here, for example, or the ID short or the display name. But the decision was to not use them, but to remodel them. Though if you have a look here, we will have a short name here. We will have the definition. Also, they are very closely related to those. So so if you use those description and ID short, this is not the one from the IEC61360 standard. Then it has the semantics of the asset administration shell. Can be used, but it's not the same. Then we have only one class for all 3 or 4 kinds of elements. On the left here, the value list. This is for the value list, as I just explained. So the cooling type was the example, the enumeration. Then for the single values within the value list, we have the value. And then for measurable properties, we do need a unit. And for this, I already explained it. We do have the unit and the unit ID. Although this is for properties with a data type that are ending with measure. Then for level types, so the only properties where it makes sense to use them from our point of view is for ranges. And if you have a property defined in a dictionary that has the level types min and max, then we use the submodel element range for it. So this is then very useful. But if it has 3 values or 4 or other combinations of these level types, there is not really a mapping possible, perhaps to a collection or something, but we wouldn't recommend to use it. It doesn't make too much sense in most use cases. Now we are talking about the data type. The data type of IEC61360 is more about a logical data type. These are all the types that are defined for IEC61360. There is an exception, the file type. This is one we added because we also have a submodel element called file. So this is not directly existing in the standard, but it's very helpful to have it. So if you have a concept description, then of course, because the asset administration shell itself is using XSD value types from the XSD standard, we do have a mapping. If you have a concept description with a certain data type, which data type should have the property instance itself. So if you have, for example, here it's easy, if there is a property with data type date, then you also would use the XSD value type date. And for string translatable, it's more complicated. In this case, we would use a multi-language property. And as I explained with the level types, we would use then range. And here, for example, the XSD does not distinguish whether something is measurable or not. You always would use integer for integer measure, integer count, or integer currency, and so on. So for real, it's more complicated how to map it. So all of this you can find in the specification, because this is important for the implementation in the end. So you might understand the concept, But of course, in the end, interoperability also means that yeah, the data types of the values, you know what it is and how they are compatible to each other. This is now the value list itself. We do model it in the meta model, in the model itself. So this is a value list, and it's consisting out of value reference pairs. And as I said, a value has a value ID, like here you see it, all the IRDIs, but also a value. In a way, this is redundant, but for better understandability, we have both the value and the value ID. Of course, they need to be consistent. So if you use this IRDI, then you also have this preferred name, in this case, air heat exchanger. So this is important to understand. This is a level type if you need it. It's of course optional, and it has 4 values. Here they are: the minimum, the nominal, the type value, and a maximum value. And you can have all 4 of them defined for a property, but as I just stated, I wouldn't recommend it. Only use min and max, and for all others you do not need any level type at all. Okay, then this was already the meta model of the data specification of standard IEC61360. And like always, I would recommend to start with the ASX Package Explorer if you want to understand the concept of concept descriptions and also this data specification I just tried to explain. It's supported by the ASX Package Explorer. The ASX Package Explorer is open source, and you can just download it and play with it and model to get a feeling about the specification. I already mentioned that there are different formats. XMI I already talked about. We have a life cycle. Every product has a life cycle, and for different life cycle phases you may need different formats, and that's why the asset administration shell provides different formats. You may use Automation ML, XML, or JSON, especially also for the APIs, OPCOR, RDF, and so on. And what we do have as part of the specification, the Automation ML and OPCOA are not part of the specification itself, but XML, RDF, XMI, and YAML for the API, they are part, and you will find them in our open source repository admin shell IO. You will also find all the mapping rules, how the meta model I just explained is mapped to these formats. It's for the data specification, it's identical to the part 1. So there is nothing special here, only the way how to implement the data specifications. And as I explained, we are using the embedded data specification approach in these files, and this is why there is one file, but they are consisting and are also containing 3A. And here also for if you are a developer where you find more code implementing the specifications, and I already talked about admin shell IO. This is the GitHub repository, or many GitHub repositories of the IDTA, the Industrial Digital Twin Association, and this is an Eclipse project. This is a top-level project, Eclipse Digital Twin, and there you also find a lot of projects that are supporting the asset administration shell. Okay, and if so the tutorial was not deep enough, or you still have questions, we also do have a GitHub repository for questions and answers. Here you might just raise an issue. You will also find the answers to questions that others already asked, and perhaps you will find additional answers to your questions there. And otherwise, yeah, don't hesitate to raise a new issue with your question. Yeah, okay. And then there is also a training from the University for Industry that is also explaining what the asset administration shell is about and how to implement it. And yeah, let's go. So that's it. Here I just have the number of members. In the moment we have more than 100 members in the IDTA. And yeah, and this is me. This is whom you listen to if you listened until here. So my name is Birgit Boss. I'm with Bosch Connected Industry. I'm also a board member of the Industrial Digital Twin Association. I'm the chair of the working group Open Technology and its working stream Specifications of the Asset Administration Shell, and 3A is one of those. But I'm also active in other organizations like Catena-X. And I'm also a PMC member of the top-level project Digital Twin I just mentioned. So now I hope you will start implementing the asset administration shell. I'm looking forward to what you are saying. Thank you very much.